Hello. Hello. Good morning, friends. Today we are going to discuss about a numerical to be solved by for relative velocity method. Okay. In the previous lecture, we have discussed about how to find out the relative velocity when the bodies are moving in a parallel plane or in an inclined plane, then motion of a link, and then what rubbing velocity of a at a pin joint. Okay, now we are going to discuss how to find out the relative or how to find out the velocity or linear velocity or angular velocity for a given mechanism by using a relative velocity method. Okay, so the given problem statement is over here is that in a 4-bar chain ABCD, as usual, AD is a fixed link and it is of 150 mm long. The crank is 40 mm long and rotates at 120 rpm clockwise, while the link CD is equal to 80 mm, oscillate about a point D. Okay, and BC and AD are of equal length. Whatever may be the length of the BC will be equal to the length of the AD. And what we have to find out? We have to find out the angular velocity of a link CD when the angle BAD, the crank is making an angle of 60 degree with respect to the fixed link that is given to us. Okay, what is our first duty? Our first duty is to find out write down the dimension. Okay, given data that AD is of fixed length, so AD will be fixed, so it will be horizontal and it will be of 150 mm long. Okay, and AB, that is AB will be the crank which is given in the problem statement and rotate at 120 rpm clockwise, while the link CD is of 80 mm. Okay, link CD will be of 80 mm, AB of 40 mm, BC is equal to AD, that is given. And as the RPM of crank is given to us, so we are supposed to find out first of all the angular velocity of a link crank or a link BA or AB. Okay, that is equal to 2 pi n by 60. So after calculation we are having some value 12.568 radian per second. Okay, before that or after having angular velocity of a link AB is calculated, we have to find out the linear velocity of that link AB, that is AB, and A is a fixed point, so angular linear velocity of a link AB will be perpendicular to the link AB, which is according to the motion of a link. Okay, the linear velocity of any of the link is always perpendicular to that link. So that's why velocity of B is rotating in this direction. Why? Because the angular velocity is given in the clockwise direction. If it is in a anti-clockwise direction, then this vector or this direction of velocity B with respect to the A will be in this direction, anti-clockwise direction, in this way. But it is rotating in a clockwise direction, so velocity of B will be in this direction. Okay, so velocity of B will be equal to some we have after calculation V equal to R omega, where omega is the angular velocity of that link, that is AB link, and length of that link AB equal to something 40 mm. So in terms of meter it will be a 0.04, and on the basis of that the velocity of BA, that is the velocity of B relative to A or with respect to A, B with respect to the A is equal to 0.503. Okay, that is a calculation we have to done before draw anything. Then after we have to draw a space diagram or a configuration diagram for the given mechanism. So we will consider a point fix somewhere, arbitrarily we choose an A point, then draw a horizontal line of 150 mm long. Okay, it is impossible to draw 150 mm if this it become tedious, so it is better to take some scale. So I will use a scale. So now what scale should be applied? Okay, what scale I am supposed to use? So it depends, the scale has to be taken on the base of the space availability with us, as well as the dimensions, a smallest dimension and a largest dimension. Okay, we have to consider both the dimension. Okay, if you consider the smallest as well as the longest dimension which is given in the problem statement, on the basis of that we have to decide our scale. Okay, if I take a 1:50, okay, scale 1 centimeter equal to 50 mm, so this AD will be of a 3 centimeter, but what about AB? AB will become a 0.8 centimeter, so it is very small in length. Okay, so I can't take this, so it is better to take a scale of 1:20 mm. If I take a scale of 1:20, or it will be more better if I take on a scale of 1:10. Okay, So if I take on a 1 is to 20 meter per 10 to mm, then that AB will be equivalent to 2 centimeter. I will draw AD. So first of all I will draw AD, which will be of 150 mm. So according to scale it will be converted into the 7.5 centimeter. So from A I will mark a point in a horizontal direction at a distance of 7.5 centimeter. Then I will draw one line at an angle of 60 degree as per given in the problem statement, that angle BAD is equal to 60 degree. That crank is making an angle of 60 degree with respect to the what? A link AD. So I will draw one AB link which is making an angle of 60 degree with the fixed link AD. Okay, and at a distance of 2 centimeter. Why? Because I have used the scale of 1 centimeter equal to 20 meter per meter mm, sorry, not a, it's not right velocity, it's only a space diagram. So 20 mm. So according to that, at a distance of 2 centimeter I will mark point B. Then I will take a distance of BC and CD in the compass, and I will mark the point C in such a way that the intersection or the arm drawn from B point and C point at a distance of 150 mm and 80 mm respectively. So one after the intersection of a arc mark from B and D, you will have a C point. Okay, now you will locate a C point, you will join ABC and CD respectively. Okay, in this way we will complete your space diagram. Now we have to draw the velocity diagram. Okay, now velocity diagram, before drawing a velocity diagram, one more time we have to consider a scale. Okay, because there is a velocity diagram, you have considered first scale is you have used for a space diagram, that will be only for 1 centimeter equal to 20 mm. Now the scale will be in terms of 1 centimeter equal to some meter per second, because we are drawing now velocity diagram. So the our scale, our right hand side will be in terms of meter per second. So 1 centimeter equal according. Now how to decide the scale for the velocity diagram? So it depends upon the first value, which is the velocity of a crank, what we have calculated from the given data. It is equal to 0.503 meter per second. Okay, so according to that I will use the scale of 1 centimeter equal to 0.1 meter per second, or on a safer side you may use 1 centimeter equal to 0.05 meter per second also. Okay, you may take. Now I will take only I will use 0.1 meter per second in my case. So if I consider a 0.1 meter per second, then this VBA, okay, that velocity will be equivalent to, or its vector will be equivalent to, AB bar will be equivalent to some 5 centimeter. Okay, as I know the direction of velocity of a B relative to A, which will be perpendicular to the link AB, as well as I know the magnitude for the velocity of B relative to A, so I can draw one vector, or I can draw one vector which, because for vector there are two parameters are required. One is a direction and another one a magnitude. A direction perpendicular to the link AB. Okay, so it means in this direction. And what about a magnitude? Magnitude will equal to 0.503 meter per second. After using the scale, 1 is to 0.1 meter per second, so it will be equivalent to 5 centimeter. So I am able to draw the vector for velocity of B related to A. But before that also, A and D, okay, point A and point D, these are the two ends of the link, AD link. Okay, these two links are fixed point. Okay, at this pin joint, both the links are, or this at this point the link is fixed. So it means that they don't have any velocities, they are having zero velocity. So this will be considered as my reference point, A and D. Okay, and the notation, capital notation ABCD are supposed to be used for a space diagram. Similarly, the same notation but in a small letter you have to use in case of a velocity diagram. So that's why A representing the A point over here, but it's a capital, it's a small. Capital D is representing a small d in case of a velocity diagram. So from A and D I can draw one vector AB bar which will be equivalent to 0.503 meter per second and in a direction perpendicular to the link AB. So I will draw one vector in this direction. Okay, up to what length? Up to the 5 centimeter. Why 5 centimeter? Because 0.503 meter per second is the value given to me. According to scale, it will be equivalent to the 5 centimeter. And what about a direction? Direction will be perpendicular to the link AB. Okay, so I had drawn A point, D point. I have marked A and D point. Now I am able to draw one vector AB bar which is lying at a distance of 5 centimeter in a direction perpendicular to the link AB. Okay, so I had drawn a B point over here. Now what is the point remaining, a C point is remaining. So what to do regarding point C? Point C is the connection is in connection with the link BC and CD. Okay, so it means that BC will have certain velocity, link BC will have certain velocity which will be perpendicular to the link BC, because every link will have velocity which will, and their direction will be perpendicular to the given link. Okay, so it means that BC is lying in this orientation of BC in this way, so velocity vector will be perpendicular in this direction or in this direction. Okay, similarly CD, for link CD, the velocity vector will be perpendicular in this direction or in this direction. Both the way it is possible. Okay, the perpendicular vector may be drawn from the towards the left hand side or toward the right hand side, or toward the top side or toward the downward side. We don't know, according to the orientation given for in the space diagram. We have to decide. Okay, now so for velocity of a C related to B perpendicular to the BC, similarly velocity of C related to B perpendicular to CB BC link. Similarly, velocity of C related to D perpendicular to link CD, velocity of C related to D perpendicular to link CD. Now what I am to going? I will draw one vector from B which will be perpendicular to the link BC. Okay, I know the magnitude, I know the direction, but I don't know the magnitude. What is the velocity of C related to B? I don't know, which is to be find out on the basis of a relative velocity method. Okay, but we know the direction on the from the given space diagram. We are able to find out the direction of each and every component of a link. For every link, their velocity vector we may decide, because it is always perpendicular to the given mechanism. So this in this direction it will be perpendicular, or reverse to that one, inverse to that one, opposite to that one. Okay, so from B I will draw one vector which will be, so from B I may move in this direction, downward direction, or I may move upward direction. Okay, so I will draw one line from this direction above. Okay, and from D, which is representing the velocity of a C related to D, so I will draw one vector in this direction. Okay, if I draw a vector from D in this direction, okay, it will moving in this direction but never may intersect with any of the vector. Okay, and if I draw one vector from B in this direction, so vector drawn from this B in a downward direction and vector drawn from D towards the left hand side is never going to intersect. So it is better to draw the vector from D towards left hand side and from B towards the topmost side. These two vectors drawn from B and D intersecting at some point, and that point is nothing but a representation of a point C. Okay, and then join this line, show some arrow. It's this arrow showing me velocity of C related to B, and this arrow CD representing me this vector representing me velocity of C related to D. Now measure the vectors CD and CB multiplied with the scale. Okay, this vector will be, if a vector will be in terms of some centimeter, but if you multiplied with the help of some suitable scale, that what you have used previously, then that vector will be converted to the velocity of a C related to D and velocity of C related to B. Okay, and what we have to find out? Find the angular velocity of a link CD. Okay, and at an angle BAD equal to 60 degree. So for calculation part is concerned, by vector AB is equal to BA is equal to 0.503. By measurement, what we find out, the vector CD is equal to something 0.385 centimeter, 3.85 centimeter. So after multiplication of 0.1 meter per second, that velocity of C related to D will be equal to 0.385. What we have to find out? Angular velocity of link CD. So angular velocity of link CD is equal to velocity of link CD upon length of that link, V equal to R into omega, but omega will be equal to V by R according to the velocity of link CD upon that length of link CD is equal to 0.385. Okay, over here is divide sign is required, 0.08, then it will be equivalent to 4.8 radian per second. Okay, thank you.